Welcome back, and in this Geo-Surface Pro tutorial I'm going to show you how to use Geo-Surface Pro for some typical surface drainage design. So I'm in the US here, I'm in North Dakota, and I've selected a field, and we're going to design some maintenance and also some new drainage for this field to try and target some problem areas that currently don't have any drainage that I can see in the data. So I've already fetched my LiDAR data, and you can see how much difference that makes just when we load that on. Suddenly we can see that there are some drainage channels in this field, and you can see the main channel that looks like it's been created running through here. And if we turn on the flow lines, again, we can see that that one's been picked up, and that actually we've got kind of two main outlet points. So we've got this outlet point here, which drains this area, and then we've got this outlet point up here. There's also another line through here, so potentially we could also use that to take us to the outlet as well. And let's have a look at the ponding layer for the field. So you can see we've got some ponding prediction areas that are sort of away from where we can see existing drains today. So for example, this area here looks like it has some ponding risk, maybe some of these areas to here. And what we can do is turn on the wetness index as well, just to give us an idea. So yeah, you can see here these sort of some of the dark blues picking up in here. So these are probably areas that wouldn't be a bad option to have some drainage, just to make sure that we give the water a way to get to this outlet point over here. And we're going to follow the natural flow as best we can in order to do that. So again, I'm going to design for surface drainage here, but actually the concept is exactly the same. If you were targeting tile, you would just be going deeper to keep the soil coverage on top of the tiles. So let's begin here, and let's see if we can profile this route down to here. So it looks like this run could come all the way, and what I'm going to do is try and make a single drain, and I'm going to bring it all the way down, and I can see from the flow lines that the natural flow doesn't actually continue this way. This is part of a different watershed that actually goes to the north. So we're going to bring the drain around, and we'll actually come through. There'll probably be a bit of a ridge here to come through, and we'll see what that one looks like. So we're going to go to the Design tab, and we're going to click on Draw Manual Survey, and then you can choose whether you're designing for surface drainage or tile. So in this case we're going to go surface, and we have to start with the main drain, and you'll see the little reminder up here, start drawing at the outlet. So the program assumes always that you start drawing at the outlet. If you start drawing at the inlet, everything's going to be backwards and things aren't going to make sense. So we're going to start drawing at the outlet, and we're just going to follow this natural flow line as best we can. And you'll notice that sometimes the flow lines have been straightened and generalized a little bit, so you can use your common sense. And I'm going to come through this wet area at a bit of an angle so that we can drain it. And then we're going to come down into this one, and then we're going to double click. And what you'll see then is the terrain profile will appear below the map, and you can always close that and bring it back at any time with that toggle. And what we'll see here is as we mouse along, you'll actually see the little cursor on the profile as well, showing you where we are. And what we've got here is the kind of the dotted line with the green behind it. That's our terrain. That's the terrain as is now based on the LiDAR data. There's a red line underneath it, which is an automatic best fit calculation. So what we're doing is actually automatically applying a best fit that would match what your machine control system would do if you were to drive that route and survey it with your RTK, which is what I want you to do. This is just a design tool. And then below that, that pink line represents a maximum depth. So that's kind of there as a reference. And by default at the moment, that one's set to 12 inches. So what we can see here is that if we were to go and scrape, because that is mostly an existing ditch anyway, and we're not going to expect to be going very deep in most of these areas, and certainly nowhere near 12 inches deep at any point, so that's good. If you want to, you can decrease or increase that maximum depth, and it's going to depend on the terrain that you're going through. So let's say we change it to 6 inches, and we can see at 6 inches there's one little spot here which has a little X on it, and that correlates to right here. We can see the X right there. It's kind of hidden behind that layer. So that just reminds us that there's a depth violation there. That's based on whatever we've set to be the maximum depth. So if I maybe change the maximum to say 3 inches and hit apply, we'll have quite a few depth violations because we'll be going deeper than 3 inches in a few places. But in general, looks pretty good that even at 6 inches, we're pretty good here, and that's just really a clean out of that existing run. So we've managed to design our first main drain, and everything looks good. And then we can come over here and we can look at some stats on here as well. So it tells us that our outlet depth needs to be at 6 inches. So in order to make this work with this much slope, and we're using a 0.05% slope by default, we need to have 6 inches available at the outlet. If that's not possible, maybe you can't go any deeper than what's already there, and we can try reducing that maybe down to 0.04. In this case, it hasn't really made any difference because we're basically following that terrain, and it looks like the field just sort of a little bit of a lip, little bit of a hump at the edge of the field, probably from historical tillage, and we'll probably be good anyway here. Looks like there is a natural watercourse right there that this all drains into. So this just gives you that information, tells you your average depth, it gives you your stats, so your average grade for the run, and also an estimated volume. So the estimated volume comes from a setting in the design parameters, which is here. And this is where you can enter in your default values. So if you want to change your default values, you're going to use that more for tiling probably than for surface. But if you use a 0.03 or a 0.08 or whatever it is, you can come and change that in here. And this implement width setting, that's where we calculate the volume from. So if you have an 8-foot implement, you put 8 feet, it'll give you a rough estimate of how much dirt you'll be moving for that run. And when you design a whole system, you can generate a report and it'll estimate the total volume for the entire project. We're not including side slopes, it's just including the bottom channels, so there will be a little bit more when you include the side slopes as well. But you can go and make changes in there for that. So now we've got our main drain, and the next thing we're going to do is we'll add a few tributaries to it. So it looks like there's some potential risk areas here, for example. So what we're going to do is click on that same button, and this time we're going to choose tributary. And when you're drawing either a tributary or a tile, lateral or sub-main, you have to start at an existing main line. Okay, it won't let me start drawing as soon as I get too far away from that main. So once I'm on the main, we'll actually snap to it, and then we'll bring this drain and we'll follow the natural run, and looks like we'll be good to stop about there. And again, we can see the similar setup. Looks like we can pretty well follow the natural terrain for most of this run here. That all looks good. And we can connect at just 2 inches, so should be all good. And what we'll see now is when we've added that connection, we can see this little check mark next to it here. So it says it's S1, so that means we've connected to the surface main drain number 1, and it's tributary 1, and that little check mark means that when we connect to the main, which is what we're doing right here, we will be coming in either at the grade elevation of the main line or slightly above it, which is what we want, and that's why that little marker there is green. So we've actually validated the connection. So we're not only checking that we comply with our depth. So it looks like here we've got, you know, this one point, for example, that's on the main. That's slightly too deep, so let's just change that to 7 inches, and then we're good. You can see the main there changed as well. When I had the minimum depth at 6 inches, you can see there's a little warning sign there because we had one depth violation on the main. If I say I'm happy to go to 7 inches, that disappears and we get a check mark there. And we also have this check mark on the tributary run, so that means that it's got no depth violations and it's connecting to the main. If we were to mess with that one, let's just say we went minimum depth of 10 inches or something like that, you can see now we've got lots of depth violations because we've actually exceeded our maximum depth in a lot of places. Sorry, we've come under our minimum depth, and then we can add an offset here, say 10 inches, push the line down, and you can play around with that. So if you want to simulate, you know, creating a 6-inch deep drain, you could set your offset depth to say 6 inches, and that'll force everything down, and then you can play with those numbers. So you can see at the moment we've got 2 X's here now on this tributary. So the first X means that the connection is invalid. So that means that if we go back and look at the main, you can see now that we're connecting below the main because we offset this run, we made it deeper, and now we're connecting too deep. It would be impossible to make that work. We'd end up with just water ponding at this connection point here now. So we need to go back to the tributary, put the values back to what they were, and we'll set the offset back to nothing, so that we'll only move the bare minimum amount of dirt that we want to, and we'll just create a very, very slight channel here just to get the water moving and connect it to that main. And then what we should see is that both of our runs are green, which means that so far the system is passing all of our verification checks. So I'm going to add a few more runs here, and I'll pause it, and then I'll come back and show you what it looks like once you have a more of a developed system. Okay, so I've added a few more tributaries to that main run, and what we can see here is overall we've got mostly green check marks, but we do have this one marker on the main line, and we also have one tributary that's showing up in purple here as well. So that's telling us that we have a slight connection violation on this tributary. So probably this one's coming in just slightly deeper than the grade of the main at that connecting location. Let's have a look at the profile for the main, and we should see that the offending connection is this one right here, which is this red one. So it's just very, very slightly below the main. In reality, we probably wouldn't worry about that because it's like an inch. But just to make the design nice, what we'll do is we'll just add a 1-inch offset to the main. We'll have to increase the max depth allowance as well. Just push that down. And then if we just select another line and then come back to the main again, just to force everything to refresh. You can see now that that one has turned green, and the tributary now has its green check mark. And when we look at all of the runs, you can see that they're all green. So that means they've all validated and everything's good. And that's what you're looking to do with your full system. So again, I'll pause it here. I'll just add a few more to the rest of the field, and then I'll finally come back and I'll just show you what it looks like when we export that out to load into a display to use to guide you out in the field. Okay, so I've made a plan for the entire field, and you can see I've used the ponding depression areas to guide me to the areas that I want to run my drains. And then I used the flow lines to guide me as to which way or how I needed to actually drain and connect each one of those areas. So what we have now, all of those purple lines represent my surface drainage plan. And if I come back to my design tab over here, you can see that everything is green. So I have had to just deepen a couple of the mains, and like just offset them by 1 inch, for example, just to deepen them a little bit, just to make sure that everything validated when it connected. but everything in here is green, which means that they're all valid and they're all good. So what I can do now is, well, firstly, I've been backing up as I go, but again, always make sure that you back up your project, because then you'll be able to restore this, make edits to it in the future, send it to anybody else that you want to be able to view it, and even if they don't have a pro subscription, they can open and restore the backup in the free viewer version. And we can also generate the reports and different overlays here as well. So I'm biased, for example, if you're using Ditch Assist, you would click on Ditch Assist image, you'd give it a name, and it'll prompt you to download two files. One is the JPEG and one is the world file. And that's what it looks like. So then you would be able to just load that into your Ditch Assist, and you'll be able to see that right on the screen when you're out actually scraping the field, so you can follow these runs exactly to make the ditches and use your grade control system when you're out in the field. And we've got various other different options here. So we've got BMP with world files for programs that use BMPs. We've got KMZs. You can also export out shape files and KML files as well, which will have the lines in. And you can also generate a report from here, so you can fill in information, check off what you need. If you want to calculate costs as well, you could put in an excavation cost per cubic yard, for example, just to give you an estimate, and then we'll generate that PDF report, and it'll look something like this. So you get a project overview, and then you get a summary of each run, total estimated cubic yards, and run by run information. So again, make sure you back up. That's the most important thing as you go. I'll see you again in the next video.